Hello everyone, we are now going to go over the peripheral blood flow cytometry plots from a 2-month-old baby with leukocytosis. The WBC count is almost 100,000 in the peripheral blood, and the baby also has some CNS involvement, which can be manifested as, headache or incessant crying, because a 2-month-old is not going to complain about blurry vision or have a slurred speech. So it will be mostly incessant crying, irritability, and headache. So when you start with CD45 versus site scatter, you see a small population in the lymphocyte gate, which has bright CD45, low site scatter, and a small population in the granulocyte gate, almost negligible, which has very high site scatter and dim CD45 than the lymphocytes. Majority of the cells are in the blast gate, that is 92%. Which has a dim CD45. In fact, it has a population, it has very variable CD45 extending from dim to almost going all the way to the left, kind of negative CD45, and they have low site scatter. And when we follow through this, they are positive for CD34, they have a partial CD33 expression, they're negative for 117, they're negative for 13, negative for 38, they're negative for 11B and 64. They're negative for 14. They are negative for 3, 7, 4, 8. They are positive, bright and homogeneous for CD19. They're negative for CD10. And they have a subset that is partially positive for CD20. So let's stop here and go over what we have so far. So far we have the immaturity marker CD34. So those are blasts. And we also have the HLA-DR positivity, and myeloid markers are almost all negative. No 117, no 13. There is a partial 33, but again, just one partial 33. 33 is, first of all, not very specific for myeloid. It can be seen apparently by any blast, and also it is partial. It's not supplemented by other myeloid markers, so we cannot really call anything myeloid just by 33. And monocytic markers are negative, 11B, 64, and 14. And T markers are negative, 3 and 7, 4 and 8 are negative. So the only marker that is lineage specific that is expressed is CD19. However, B lymphoblasts are always positive for CD10, or we can say mostly positive for CD10, really bright positivity. Here, CD10 is completely negative. So in that case, we need more markers to call it BALL. 20 is not very helpful here because we see only a small subset expressing partial 20. So we have our cytoplasmic tube with CD22. So let's see if that is helpful. Here we see that MPO is negative, 34 and 19 again positive. CD19, CD9 shows a tight cluster of positivity, partial positivity, and CD22 is partially positive. So that helps. TDT is partially positive. So here we have CD19 expression that is supplemented by CD22 expression. So we can call it BALL. So there is an entity in BALL with recurrent genetic abnormalities that is usually negative for CD10. So that is BALL with KMT2A rearrangement. So earlier it used to be called as MLL rearranged BALL. So MLL rearrangements, they can be seen in AMLs, in ALL, in biphenotypic. So in BALL, they usually are 19 positive, 10 negative, and they can sometimes, they often express CD15, and they are very common in infants, and they are not common in infants. They commonly occur in infants, and sometimes they can be positive even in utero, and they often involve the CNS. One more thing is these blasts that express a tight CD9 expression against a heterogeneous expression. That is a clue that these are neoplastic blasts, because B lineage blasts and hematogones kind of have an overlapping phenotype, and we'll go over that in in some other chapter. But here, when you CD9 is helpful because in hematogones it will be more of a heterogeneous expression, but in the lymphoblast it will be more like a tight cluster. So that's the utility of CD9 in B lymphoblasts. So it also helps in the follow-up for when we do for MRD evaluation. So in this case, your top line would be B lymphoblastic leukemia with 92% blast, and in the description, we can give the phenotype and say that the 10 negativity suggests an MLL rearrangement or a KMT2A rearrangement correlate with fish studies. Thank you.